This section we're going to talk about sampling, frequency distributions, and different types of graph. Example 1, the following list gives the 2008 through 2009 tuitions in thousands of dollars for a random sample of 30 private colleges that offer 4 years degree or higher. So when you see 23, it means 23,000 is the tuitions. 22,000, 38,000, 25,000, and so on. So all these different private schools have different tuitions amount, right? Using these informations, the first thing we wanted to do is find the frequency distributions. Okay, so in order to find the frequency distributions, I need to be able to differentiate different parts. So let's see what I'm going to do. I'm going to draw the charts. And then the first part, I'm going to write the amount of the tuitions or tuitions amount. And then I need to count that. So I'm going to use the lines. And then I'm going to have my frequency here. Okay. And so because I don't want it to write each value, let's make it range. So maybe I will start from 5 to 9. And 10 to 14. This is something up to you how you want it to differentiate. So this is something you can do. Or you can do like 1 through 9, right? And 10 through 20. That's completely up to you. Sometimes they ask to use certain range, but here they didn't mention anything about it, so it's up to you. So let's just use the 5, difference of 5 this time. So then you have 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, right? Then we are going to start count. So the first value you have here is 23. So let's start count. 23 will be right here. Then you have 22. 22 is the same locations. 38, 25, 11, 16, 15, 26, 23, 24, 37, 18, 21, 36, and you have 236, right? 36, 28, 18, 9, 39, 17, 27, 24, 12, 32, 24, 27, 22, 24, 28, 39. And then let's give the frequency. So you have 1, 2, 5, 9, 6, 1, and 6. And when you add them up, you should be able to get your total number, which is 30. This is how you're going to check if you check the values right or wrong, right? And this is what we call frequency distributions. So just looking at it, if we have a table like that, given values like this, right? Given values like this or a table like this, what will be easier to see or analyze the given values? Well, this, right? Because we can tell, oh, we only have one, the lower value as 5,000, 9,000. We have 6 of the school, their tuition is over $35,000 to $39,000, right? But it looked like it's more likely bell shape. So this is going to go higher, right? In the middle is higher and then getting smaller. And this is maybe exceptions, one of the exceptions. But it goes small to higher like this, right? So the averagely, this is the amount where most school tuition is tuition amount is 20 to 24, 25 to 26, 15 to 19, right? This is where most school tuition is. And that's something we can see better as a frequency distributions than if you have just the number written. I have no idea what value is more and less, right? This way. So this is easier to read your data. So then let's look at histogram. Histogram is the graph, basically. So histogram, it shows you this frequency distributions in a picture form. So let's see how we're going to write that. So this is going to be the chart with the graph. And this is going to be my frequencies. And it starts from 1 through, the highest number here, frequency is 9, right? This is 9. Start from 1. So I will do 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9, and this is 1, 1, 2, 3, 4, 5. This is 5, right? And then, in order to draw my histogram, that's the bar graph, I like to mark in the middle. So between 5 and 9 is going to be 7.5. So that will be 7.5. Between 10 to 14, the middle is going to be 12.5. And then 17.5, 22.5, 27.5, 32.5, and 37.5. So the first one, 5 through 9, I have only 1. So that's going to be 1. And then 12.5, which is the value between 10 to 14 is 2. So that's going to be 2 right here. And then you have 5, so all the way 5 somewhere here, right? And then you have 9 all the way top. And you have 6 and 1. And another 6. And this is called histogram, the bar graph. So again, with the histogram, you can see that the middle groups is higher, middle group is higher, and goes smaller this side, right? That's why I say it's a bell shape like this, right? Exception of this one. And we call this outlier, right? Because if it wasn't that, it will be exactly normal distributions, which is the bell shape, right? And we're going to go over normal distribution in later on sections. So this is what histogram is. And C is asking frequency polygon. Frequency polygon, I can just show you as the different color. Let's call this C, frequency polygon, the red. Frequency polygon is basically the line charts. So in order to draw the line charts, you need to have points and connect that points from here, that, so those red line is what frequency polygon is. Okay, then what about stem and leaf plot? Stem and leaf plot. Let me show you how stem and leaf plot is different than frequency distributions, right? So it's similar. We will have stem and we will have leaf on the other side. So stem is going to be our 10th digit value. So if you have 1 through 9, you're going to write it in this line, right? If you have 1 through 1 through 19, you're going to write it in this line. You have 2, so 20 something, right? You're going to write this line, 3, 30 something, and that's what you have, right? You don't have 40. So then looking at your given data, this data right here, you're going to do exactly the same thing as what we did the frequency distributions. So if we have 23, the first one is 23, then I'm going to write it as this is 20 and then write it 3, right? And then you have 22, you have 38, 25, 11, 16, 15, 26, 23, 24, 27, 18, 21, 36, 36, 28, 18, 9, 39, 17, 27, 24, 12, 32, 24, 27, 22, 24, 28, and 39. So the difference between stem and leaf plot first, frequency distributions here, is that your n numbers, so your first digits are gone. So if you have 2 numbers between 10 and 14, but you don't know what exactly that value is. It could be 11, it could be 13, right? So we know the range of that, but we don't know exact numbers. But for stem and leaf plot, you do know the exact numbers. So you have 11, you have 16, you have 15, you have 18, right? Exact number. But at the same time, you can also see, well, most schools tuition falls in the middle group, which is 20 something, right? 20 something. And this levels, again, it's up to you to write. If you wanted to differentiate like this one, where it was differentiate in unit of 5, that's something you can also do it here, right? So if you want to, you can do one here and another one here. So if you wanted to write between 10 to 14, you need to write it in the first one. If you wanted to write 15 to 19, then you need to write it in the second one, right? It's just up to you how you want it to differentiate. So again, stim and lit plot, you end up seeing all the data and you don't lose the numbers. And at the same time, you can see the graph form of it, right? That's the difference between frequency distributions with stim and lit.